Okay, so we've just looked at well, we're looking at the particle model of matter, and we just basically refreshed our sort of key stage 3 knowledge, really. And so imagine 9 particles arranged in different ways to demonstrate themselves as solids, liquids, or gases. So this is a solid, and we all know it's a solid. We can say straight away, but what you do need to know is how to be able to describe it with words, why that is a solid. And it's a solid because the particles are relatively close together and they are in a fixed pattern. Now, that's just describing the picture, really, but you still need to be able to know how to do that. They also want you to actually talk about what is actually happening, because this is a still image. So if we were watching these particles, how would the particles be behaving? And you can't obviously draw that, so you would write that. The particles are in a solid, vibrate around fixed points. Just to be clear what I mean by that, if we zoom in on one of these atoms, what it means is that particle there has a point. There's the middle of that atom. Now, the particle, it might move up a little bit that way. Let's just turn off smart drawings. But it's always going to come back here, and then it might go down again, right? It might go out a little bit that way, but it'll come back down here again. So, and the same with all the rest of them. So they vibrate, but around fixed points. It's like they're all stuck on a sort of a spring, and they kind of go further and further apart. Now, what we haven't, they go further apart and they come back together again. Now, what we haven't talked about yet is how solids and liquids and gases behave when you heat them up. Now we know that they're going to, when we heat up a solid, it's going to melt, but it doesn't melt immediately, does it? There is something that happens between the state of going from a solid to a liquid. So we're going to talk about that next, but let's just summarize what we've talked about so far. So in a liquid, we have them now still relatively close together, but this time they're not really arranged in any particular pattern. So how do they behave if we were actually to watch them? They don't just sit still like they do in a solid. They flow past each other, but they stay close. So they stay as one big group, but they can still flow by each other. Now I'm going to demonstrate this on my diagram by drawing little arrows like this to show that they're kind of moving around, flowing by one another. Now, both of these pictures, we've drawn them as if there's gravity. And we can tell that because this liquid, they've all arranged themselves at the bottom of the container, and the solid has fallen to the bottom of the container. The gas is, well, this is basically as if there's gravity still, because it wouldn't really behave much different. There is a slight difference. Even gases respond to gravity. If you get enough of that this gas, you're going to have it's going to be higher density down here than it is up here, because they still feel the force of gravity, but it's much less noticeable than solids or liquids. So you have to describe this picture. Again, by the way, just maybe focus a little bit more on liquid for a moment. This is the hardest one to draw. Make sure that it's not in a pattern, but it is close. Okay. Now, yes, and this one, they're not in a particular pattern. Be careful about this. I've seen people drawing liquid gases like this. This would not be okay. They're far apart, but they are in a pattern. So just draw them any old how, no pattern, and that's a gas. Okay. I would also go further to draw larger arrows, like the arrows that we had in the liquid, but larger ones to show that they're moving faster. Now, the arrows can be different lengths, but they have to be, on the whole, larger than they are in a liquid. You're still going to have some particles that are moving a lot faster than another one. And in fact, that's what we will look at, about this distribution of speeds later on in this unit. But the particles do not move at the same speed, but on the whole, they move pretty fast, and a lot faster than they do in a liquid. So not any particular pattern, not touching, and moving around randomly. Now, what we want to know what we want to be able to say is how these particle behaviors explain the properties that we observe. So we can't, clearly none of us have ever actually seen a particle or an atom or a molecule in real life, but we have all seen water, liquids and gases, and we know how they behave. We need to be able to put those observations into words, and we need to be able to explain those observations using this model of matter, this particle model of matter. So solid, we know, has a fixed shape and a fixed volume. Well, this explains why it has a fixed shape and a fixed volume, because the particles vibrate around fixed points. The whole thing takes up the same space, and this is only at a fixed temperature. A liquid doesn't have a fixed shape, so it will just take the shape of the container, but it does have a fixed volume. You can measure the volume of a liquid. You pour it inside a measuring cylinder and it all sits to the bottom, so you can read what volume it's taking up. If you poured a load of gas into a measuring cylinder, it would just spill out and go all over the lab. So it doesn't work. So gases do not have a fixed shape or a fixed volume. So hopefully you can see how these models explain those properties. So we've got a simulator down here. I won't go into that now because I kind of already explained all that stuff there. But just one last thing, just to emphasize that the particle model of matter, don't get too stressed out by the phrase. A lot of people think, like, what even is it? It's simply saying that it's the model, it's the idea that, or it's the theory, or the model of reality that said things are made out of particles, and that's it. That's the particle model of matter. And then we use that particle model of matter to explain various different things and some particularities. Part of the particle model of matter is something called kinetic theory. And actually, really, what I've been talking about so far is mainly just the kinetic theory aspect of it. So how particles behave in terms of their movement, their kinetic energy.